It's nice to be back in Kiev. I've been here like the last 4 years in a row, so it's always nice to come back to a conference that I really like. This is a talk called "Can TypeScript Really Help Make Infrastructure Management Easy?" My name is Paul Stack. I work at a company called Pulumi. Does anyone know Pulumi? A few people. I'm impressed. Okay. Anyone know Terraform? Yeah, so Terraform is like a much more well-known tool in the area. Pulumi is a much smaller tool. This is not a sales talk, okay? It's not. Everything that I am showing you today is open source, and you can try it and use it as much as you want without paying any money, okay? The purpose of this talk is not to sell you things. The purpose of the talk is to show you that there is alternative tooling now available in this space. So Pulumi, like a small background on the company, Pulumi was actually born out of 3 people who worked at Microsoft. Okay, so we had Joe Duffy, who's the CEO, Eric Rudder is the COO, and Luke Hoban at CTO. And these people not only worked at Microsoft, but Luke went and actually worked at Amazon in the EC2 division, and they noticed that there was still a gap, even though there was like well-known tools like Terraform and ARM templates and CloudFormation, that there was still a little gap in the market because not all tools were created equally, and different people have different perceptions of tools, so they decided to start making their own. So the reason they started to do this was because we've had an evolution of change in how we actually build our infrastructure. Okay, so we have like version 1 infrastructure, and I'm not saying if you're on version 1 you're way behind. That's not the case at all. Version 1 is traditional VMs. Okay, like EC2 instances with security groups and like backed by traditional RDBMS databases and so on and so forth. That is like what we call our like traditional style infrastructure. Think of like an N-tier application, okay, where you have an application that's load balanced across a number of instances, and those instances talk to a database instance, or even if it's not in the cloud, it can be in a physical data center. And then we started getting in the era of V2. Okay, then everyone heard the term cloud native. So cloud native is a new thing in the past few years where we've started creating microservices that go inside containers, and now those containers not just run in like on machines themselves, but they've started running on orchestration platforms like Mesos and Kubernetes and so on and so forth. So it's very difficult to do a talk at this time because there's a competing Kubernetes talk on, but I'm actually going to show you some tips in order to make your Kubernetes life a little easier. But anyway, and then we started going into V3. And there are a lot more people going into this V3 era than we originally had to think within cloud computing. And this is where we go into like functions and serverless. Anyone doing functions? Azure Functions or serverless Lambda? That type of stuff. So, because there's these 3 because there's these 3 phases of infrastructure, traditional tooling up until now didn't really cross all 3 tools. And this is where Pulumi has aimed to do. So Pulumi is much more aimed at allowing you to mix and match your infrastructure types rather than traditional DSLs or JSON or YAML or so on and so forth. And Pulumi is broken down into 2 things. The most thing that we're actually going to talk about today is the Pulumi SDK. So this is all the open source stuff, okay, that you can use, the backends, the secret management, the actual CLI. Everything that I show is open source. Okay, all of the code is open source entirely in Pulumi except the SaaS. The SaaS is what you pay for. And what we try to do is we try to say that infrastructure isn't really code. Infrastructure is more software. Okay, so we're trying to bring the management of infrastructure into the hands of the people that manage the applications, because we're starting to hear more that, you know what, if you run it and if you build it, you run it in production. So therefore, there should be a much more close tie between the infrastructure and the code that you actually write. Pulumi has 4 main use cases. Okay, so on the top right-hand side, we have infrastructure, and that's the traditional V1 infrastructure. Okay, and let me see if I can. I don't know why it won't let me zoom that in. Dope. Let us go and. Well, I've just broken it completely. Anyway, so I'll show you actual physical code. It's easier. So it's much more traditional physical infrastructure. So we have an instance and a security group, and we have like constants being defined and so on. Then in the top left, we have containers. Okay, so we have like nice, simple typed documents across the top of containers because it's 2019 and who really likes JSON? And then on the bottom left, we have Kubernetes. And again, Kubernetes, we have like actual real types across the top of Kubernetes rather than using YAML or Helm. And in the bottom right-hand side, we actually have serverless. Now, for those who can see the slides will be available afterwards, is that because we're an actual language rather than a DSL, you get extension methods and helper methods based on the back of what you do because it's real types being passed around. So therefore, we create an endpoint, and then we can say endpoint dot and a get method, and we can actually pass in like a specific lambda for the get method and so on. So let's talk about infrastructure as code. When I say code, I really mean code. Because we can take advantage of real programming constructs. We can take advantage of conditions and loops because we use them in everyday development practices, okay? We don't write code in a way that we can't take advantage of reusable components and conditions and loops and so on. So we've introduced these into infrastructure management. We can have multi-provider workflows, so if you're already used to Terraform, you can still use those multi-provider workflows. So you can have like AWS and DN Simple and a monitoring endpoint all within the same application in exactly the same way as you can other tools. But for us, we start to go a little further because the reusability side of things is a little more interesting than normal. So like, for example, we support 5 languages, okay? We support JavaScript, TypeScript, which we're going to look at today, Python. And then the 2 latest languages in preview are Go and .NET. So, and .NET actually is like C#, F#, and if you want to, VB. So, you know, you can start to bring in a lot of different things. But each of those languages have their own packaging ecosystem. So therefore, you can actually package Pulumi code up as adherent to the actual ecosystem itself and actually pass it around, or, you know, with correct versioning and correct strategies of who can see it and so on. But one of the most interesting things for us is that we actually enable advanced orchestration. We are code, and because we are code, you can talk to APIs and you can talk to SDKs. This is where we are a little different to more traditional tooling. So this example basically says, I want to deploy a canary of my application in Kubernetes, and I want to take 3 replicas of that. After that has been deployed, I then want to write a check against App or Prometheus, and we'll get the result back of the check. And then in the last part, we basically say, if the check passes, because we actually do an annotation against metrics checked, then we actually will roll out the last 10 replicas in the set. So because of this, we can actually start to create these real deployment workflows using the same tools that you write in every day. So that's the slides done. We're going to talk about demos. It's much easier to show you demos to show you what can happen and what cannot. I am going to... So Pulumi is a CLI, okay? So you just brew install Pulumi if you're on Mac, or there's a curl command that you can download it, or a PowerShell command if you're on Windows. And it has a lot of different endpoints. But by default, Pulumi new is how you create a new project, okay? When we ask Pulumi new, it will ask us what type of application, I apologize, make their demo 1, cd demo 1. So Pulumi new. And it will ask us what type of application we actually want to create. And we've created some sample starter applications so that you can see the structure of how a Pulumi program actually works. So today we're going to choose AWS TypeScript, because all my demos are in TypeScript because it's nice and simple. But you can see that there's Kubernetes examples in GCP and Azure, and if we go further down the list, we can even see more. So like OpenStack, Packet, Linode, and so on and so forth. So today we are just going to say AWS TypeScript, and it will create an application. The first thing it will ask us is, give us a project name, okay? It usually, by default, uses the name of the folder, and I'm just going to say XP Days 1. You can give it a description if you want, and then we ask for a stack. If we think of stacks as a way of segregating infrastructure or different elements of infrastructure, it's a way of segregating our infrastructure so that we can deploy multiple versions using the same code, but without using the same configuration. So let's think of a development stack, a testing stack, a staging stack, or a production stack. But it can also be developer 1, developer 2, developer 3, and developer 4. And they're all using the same code. They can deploy independently of each other and all use different configuration versions if they need to. So it's a way of being able to reuse code and segment different things around. We're just going to say dev because it doesn't really matter in this case. And lastly, because it's an AWS provider, it's going to say, where do we want to deploy it to? And I'm just going to say US West 2, because my VPN is pointing to US West 2. And what it's going to do, it's because it's JavaScript, it's going to install the entire internet, and it'll take a second. And I can open my IDE. And my IDE will refresh in a second, hopefully, when it's finished. Come on. There we go. And we have demo 1. So it has a git ignore, it has a node modules folder, it has an index.ts, package.json, it has our dev configuration where we actually configured something. They say US West 2, and it has the type of application and the name of the application, and it has like some configurations so that we can lint things. The most interesting thing for us is index.ts. So what this actually does, this declares that we are going to create an S3 bucket called my bucket, and we'll look at the name in a second. And then when it's finished in Amazon, it will give us that bucket ID back. Okay, so I can go and I can say Pulumi up, and it will take it will have a look at what's currently on my local machine against what's in the cloud where I've programmed it to, and it will give me a plan to come back. So in this case, it's going to say it's going to create a bucket, and we can see the details of what the bucket is. Now, notice that the bucket name is not my bucket as we expected. The bucket name is my bucket dash a random prefix. We do things a little differently to other tools. The reason that is that there are a number of operations in the cloud where you want to create a new one before you delete the old one, okay, for high availability for your end users. An S3 bucket is a great example of that. You cannot create an S3 bucket with the same name as an existing S3 bucket. So therefore, we append a random string on the end so that you can deploy the new one and replace the old one gracefully. Okay, the same thing would happen with a load balancer or an instance or anything like that. So you can turn this off and disable this. And what we would do here is we would say, because as part of the name, we also have arguments that we can pass in. So in this case, we would say bucket is, I'm going to call it XP days demo. Now if I go back to Pulumi and say Pulumi up, then I'll actually get the physical name, in this case, of XP days demo. If it ever works. There we go, the details, and we can see right here, XP days demo. So it's exactly what we expected, and we can say yes. So it's very simple and very easy to deploy a very simple example. But that doesn't really take advantage of any of the program constructs. That just shows you the fact that we can deploy something and we can actually modify something and change it and so on. In fact, I can go back and I can say tags. Oh, look, I'm actually using my ID here. So I can say name and I can say managed by Pulumi. And if I really want to push something, I can say a broken parameter. True, oh, excuse me. And look, my ID is even telling me that doesn't fit in the current struct. Because it's a typed language, it understands exactly what's happening under the hood, so therefore it will actually tell us in advance if there are any problems. But as well as that, we can step in and we can have a look at all the different options, and we can use our IDs in order to move around or Vim or whatever you use on a day-to-day basis in order to actually see what's there. And we can go back and we can see that there you go, XP Days demo is available and everything is there. So let's go and make a second demo. Let's go and make a more advanced demo. Demo 2. And we're going to say Pulumi new AWS TypeScript again. And we're going to say XP Days 2. US West 2. And now we can start to do something more interesting. I've pre-created some code here. I don't want you to have to watch me type all day. That's boring for everyone. And I go back to my IDE. So in this case, we're doing something more advanced. Okay, the first thing that we're going to do is we're going to go off to AWS, and we're going to get an AMI ID, because we can always look up from the data sources that we need. And in this case, we want to go and look up the AMI ID for Ubuntu 18.04. Then we're going to create an SSH key and a security group. And the more interesting thing is we are going to create an instance, an EC2 instance. Now, there's a few different things happening in here. Firstly, we are, of course, using the output from other pieces of the program. But the most interesting part is that because Pulumi is a typed language, we can create constants so that you don't have to actually remember strings. Okay? So magic strings are a real pain, and we always forget what magic strings are. So when you do something like instance types, in our IntelliSense, we can say, I want an instance type of, and it gives us all the instance types that are available inside your system. So life is a little simpler and a little easier. And if you actually, like, for example, go to RDS, and we say instance types, then it'll show us all the RDS instance types, and so on and so forth. So I'm just going to go back and just change that back. Oh, and if you see, I'm passing an RDS instance type into an EC2 instance type, and it immediately tells me before the program even runs that there's a problem, and we can understand that there's something wrong. If I just go back to this. Okay, and then lastly, what I want to do is I want to export constant public DNS equals web server dot public DNS, and we can actually see and we can get that. Now, I'm not going to run this because it takes a couple of minutes and it's just going to be a waste of everyone's time sitting here. But this shows us how to do something very simple. Just create one piece of information. We're using JavaScript, and because we're using JavaScript, we can do some dumb stuff, really dumb stuff, but in a good way. I promise you, in a good way. Okay, so let's look at what happens if we need to create a group of web servers. Okay, so what we can do is we can say constant web server count equals 15. Okay, and then we, instead of just declaring 15 instances right here, we can say for let I equals 0, I is less than the web server count, I plus plus. We're in a language, okay? Now, when I loop over them, I want to maybe collect some information. And here's where the stupidity of JavaScript comes in. This is why I love JavaScript for this type of stuff. Let web servers equals an empty array, an untyped array that we can just push things into. Okay, cool. So we can grab this code right here. Oh, excuse me. We can grab this piece of code right here, and we can actually say web servers dot push that entire code block in. Now, I've refactored that. Okay, my ID has immediately told me that web server no longer exists, and I'm trying to pull information out of my web servers. Now, what I can do is I can say web servers dot, and because it's an array, I can say map, and I can have a lambda, which basically says s dot public DNS. At that point, it will loop through all of the items in the web server and pull out the DNS items. And we can refactor this even more. Okay, so let's create a file called web server. Okay, and let's move some pieces of information in here. Let's take this count and take, you know what? It's easier if I just go and do it properly. In webserver.ts, I'm just pasting from the iPad. We're moving the key pair, we're moving the security group, and we have now exported a class. Okay, we're no longer exporting types. We're really actually got inheritance that we can pass around, and we can actually pass around real types. Okay, and this class has a constructor where we pass the name, the AMI ID, and the instance type in, and it will do exactly what it had to do before, but based on the types that we pass in. So this is a really simple reusable class. And if I go back in here, I can actually say web servers.push instead of AWS EC2 instance. I can say new web server, and immediately my ID is picking up that it's in a different class, and I can grab that, and it has imported the correct type, and the instance that I'm going to say is we need a name, so the name will be web server dash $I, because everything in Pulumi needs a unique identifier. We also need to pass in ubuntu.id, because we actually need to pass in the AMI ID, and more interestingly, we need to pass in ec2.instancetypes. And we'll say t2 small. So at that point, we actually have a real loop. Oh, I removed that. Let the web server count equals 15. Okay, so we have our loop back again, but this is a reusable type that can do many different things. In this case, it's creating a security group, and it's creating an SSH key, but of course you could like tie in instance rules, IAM rules that you as developers, you don't need to care about, but your operations team are like, they're in charge of, and they actually allow you to do it. Now, we have something to take care of here, because the web server isn't a collection of AWS EC2 instance types anymore. It's a collection of web servers, and a web server has a VM inside it. So we can say s.vm.public-DNS. So by very simple refactoring, we've been able to actually break down the application and continually modify it until it's exactly fit for purpose. Any questions on that? You can interrupt me, I don't mind, I promise. Okay, so let's see what we can do, because I've just showed you that we can use APIs that are existing. Okay, and because we can use APIs that are existing, life can be a little easier. Let's go and have a look at code, cd go, source, GitHub, Pulumi, examples. So the Pulumi GitHub repository has a ton of published examples, and I really mean a ton of different languages, different clouds that are all there, and everything is like stuff that we continually maintain. Okay, we're going to use a couple of these today. So I asked about functions. Anyone use functions? I'm going to show you why we can actually make life a little easier using these types of systems than some other tools. So let me open up the IDE, and if I go to Azure Functions, Azure TS Functions Raw. So that's TS Functions. Okay, cool. So this specific function has a function in .NET, a function in Java, a function in JavaScript, a function in Python, and a function in PowerShell. Okay, and for those who know Azure, when you deploy an Azure function, you need a number of different components. You need a resource group. You need an Azure storage account. You need an Azure storage container. You need a zip blob. You actually need an app service plan, and somewhere that it's going to, like the zip blob will read where the application is deployed to. So that's 7 pieces of infrastructure. Okay, and because it's 7 pieces of infrastructure, we sometimes make a lot of mistakes when we try and repeat stuff. So we've been able to create higher level API abstractions across the top of these different pieces of information that allow life to be easier. So let me show you an example. These lines of code right here will create a .NET Azure function. What it will do is it will point to a folder location. In fact, we can do that. We can say .NET cd Azure TS functions raw, and we can say .NET build cd.NET. And it's just going to do a very simple build for .NET. It'll only take a second. And what it's going to do, it's going to point to a specific folder location inside OBJ. Okay, this is like inside the internals of a build. And it will use what's called a file archive. So we're pointing to a raw location on disk, but Pulumi is clever enough to understand that it needs to zip up the contents of that location and use that as the archive. So it then passes around the entire archive object to be used. And under the hood, what it's doing, if we go and ever, let's just cancel that build just because it takes a little longer. And now I've just broken my machine. Amazing. There we go. Come on. Why do you do this to me? Source, GitHub, Pulumi, examples, Azure TS, functions, raw. And if we npm install, it'll just take a second. But we effectively will be able to step in and we will see that it actually is a wrapper for many different resources over the top of the hood. There we go. Come on. Give me code completion, please. There we go. And inside this, we can see that it does a number of different things. And a number of different things are all in here in this class. So this is like a maintained class by Pulumi. And because of that, we actually will create these higher level API abstractions for you. Now, we can use the same style, whereas for a Node application, it's only 4 lines of code. For a PowerShell app, it's the same as .NET. For a Java app, it's slightly different. And we can actually, like, Python is pretty similar as well. Now, if I were to run this, in fact, we can run this just to show you. Let me just, this build is never passing and I don't understand why. So I just take out the .NET one and I'll take out the Java one just because they actually require real compiled systems. And if I Pulumi stack init, because we need to create a new stack in this case, we're just going to call it dev. And if I Pulumi up, it's actually going to tell me that it's going to create a number of resources, whereas we've actually only specified 5 in our code. So Pulumi is clever enough to create these higher level abstractions across the top of it, and it will understand that you can group all these different pieces of information. You're probably thinking, why is this useful for me? Excuse me, I apologize, I forgot to set some configuration. West US 2. You're probably thinking, why is this interesting for me? So let's think of you being a developer. And as a developer, there are certain parts of the system that you don't really need to care about. Networking is a great example. Okay? If you're in AWS, wouldn't it be very useful if your operations team or your infrastructure team or whatever you call them within your organization was able to give you a package that you have an API that you can program against that basically says, give me a VPC. Inside that VPC, I need it to have 2 availability zones. I need to have NAT gateways. I need to have an RDS instance or whatever. All of these different pieces that you as a developer don't really need to care about. What you want is somewhere where you can test your code. So by using these higher level abstractions, we can give you that. Not just us as Pulumi, but we as developers, we as operators, we can give you a very simple way of doing it because Pulumi has this idea called a component resource, and a component resource is this grouping, which is what has been allowed us to create this Azure app function. And we can see it's going down the list and it's deploying them, and it's trying to do as many of these in parallel as it needs to. And it'll eventually give us some outputs. Come on, please give me an output. Sometimes it's a little slow. I'm like deploying across to the US, so it was silly to start my VPN in America. I apologize for that. But it'll take a second. Now, as well as this, it's really important to say that if you're from the Terraform world, okay, when you're in Terraform world and you use modules, okay, your structure of your code is sort of, and your state is very much tied to that module. Once you deploy it, you then have to use like Terraform state remove, Terraform state add, and move it around that different way. We don't use state in the same way that Terraform does. I'm not saying we're using it better. I'm not saying they're using it worse than us. That's by no means what I'm saying. There is a different paradigm here. None of our state is related to anything to do with the structure of the code. Okay, the state for us is actually, and we can have a look at it, Pulumi stack export. I'm just going to grab this URL. Oh, I missed it. I'll come back to it. The structure for us is the name of the stack, which here is dev. Okay. Then we have the project, which is called Azure Functions Raw. Okay. So the overall project within Pulumi where you're deploying your infrastructure. And then we have it's the Azure provider, the version of the provider it was deployed against, and then a random ID. Okay, so you can move that around, you can rename it, you can do different things to it and refactor it as much as you want because it's not tied to specific individual structure. Okay, so it's a different paradigm. And if I Pulumi stack export again, output, then I should see my 3 outputs. And I can take one of these and I can go to the UI and it should start pretty fast. I can start 2 of them actually. Oh, there you go. Look, hello Node.js from Pulumi it says. Maybe. Where's it gone? Where have you disappeared to? And we can start the Python one at the same time. I don't understand where that Node.js one is gone. And we can say hello Python. Oh, that's why. Hello from Python Pulumi, hello from Node.js Pulumi, and so on and so forth. So it's the same code base deploying multiple versions of the application, and we can collate the results coming back from it. Anyone use Docker? Everyone knows Docker, right? Anyone not know Docker? Like it's a pretty standard thing these days. So if I do Azure App Service Docker, so this is a more interesting situation because as well as being able to deploy individual pieces of information, we can actually leverage shelling out to other programs from Pulumi. Okay, so if I show you this specific app, we have an example called Azure TS App Service Docker. And inside this, we're going to do a number of things. Okay, the first thing we're going to do is we're going to create a resource group. Then we're going to create, on that resource group, we're going to create an app service plan. Okay, then we're going to create the app service for that plan, and that service will download an image from the Docker hub. Okay, so that's one variant of what we're trying to do. So it's not doing anything on my local machine, it's all doing it in Azure. The second variant of this is I have a custom node application right here, and it's a very sophisticated application. It says your custom Docker image is running in Azure App Service, and I'm actually going to say your XP days one, just so that you can see that I've deployed it live from my machine. And it's going to take it, it's going to create, as part of the resource group earlier, it's going to create a registry, a container service registry. It's going to use Docker image, which will build using local Docker, that image, and it will ship that image up to the registry using the server, the username and password from the resource that was previous, and then it will actually run the application and give us the URL back. So let's try it. So the first thing I need to do is Pulumi stack init, because we need to create a new stack. And I'm going to say stack dev, that's fine. And then Pulumi config set. Okay, so this is application level configuration that you need to share across your entire Pulumi application. This is where you can do things like secrets, usernames, IAM roles, anything that comes from different parts of your system that need to be passed into your application or your infrastructure. I'm just going to say Azure application, and I can say Pulumi up. And if I really want to, I don't have to look at what comes back in the first time. You can say yes. Oh, let's npm install. You can see I haven't actually done this, so I'm trying to do it live to show you that it does work. Fingers crossed. And it'll take a little second. Come on. And if I Pulumi up, yes, which means I don't have to actually say that I want to see the preview. It's just going to skip it and accept the preview by default. Then it's going to do a number of things. But the more interesting thing is you're going to see right now, it's going to create a Docker image. So if we have a look at this create, you're going to start to see, in this bottom part, you're going to see that it does like Docker commands. Right at the bottom here, you're going to see like a Docker run, and you're going to see a Docker login, and you're going to see a Docker push, and all of these different pieces of information. And I'm really hopeful I have Docker running on my machine. I don't. That'll be a problem. Come on. It'll start in a second. We have 11 minutes. We have plenty of time to do this. Although it is Docker, it might be slow. Come on, start for me. There we go. So Docker's running. And it'll come back and say it failed in creating the container, and we can do that. So I'll just leave that one for a second and then come back to it. I have another demo where that can, oh, there we go. Very good, very good, very good, very good. So we can say Pulumi up, yes. It's going to accept it. It'll skip straight through it. And it will actually, this time, you see that? It was doing the Docker login, the Docker context, and it's pulling the file systems. It's doing all of the exact same like commands that you would do as a Docker run, but it's packaging it up in a very simple way, a nice interface that means you don't have to actually care about these commands. And it's pull complete, and then it'll actually push that up into the registry very shortly. So while that's running, we'll come back to this example in a second. Pulumi POCs. There we go. So I'm going to make their secret. One of the things that's painful is secret management. Really painful in the industry. We're not good at it at all. And usually when we use like CloudFormation or ARM templates or Terraform, we have to use like a supplementary tool that goes on top that will actually allow us to do secret management in a better way. We have tried to make secret management first class in our system. Okay, so what I mean by that is it is baked in by default that you can make anything a secret, and I really mean anything. So let's Pulumi new TypeScript, and we're going to call it secret, and we're just going to say stack dev. And I'm going to use a random provider. So random provider allows you to create things like random passwords, random usernames, like just random email addresses. It's just there just to help you if you like testing examples. And I'm going to say npm install Pulumi random, which will actually bring in the correct package. And I'm going to do one thing in here. So if I go back to my ID, I go into secret and index.ts. First thing I'm going to do is I'm going to create a random password of length 16, and it'll have special characters. Okay, and then it'll export that random password for us. And I specifically want to show you, if you don't use secrets, what actually happens when you use infrastructure management tools. So if I Pulumi up, anybody tell me what's going to happen? Do we think it's going to push it in plain text or encrypt it? Plain text. Okay, why? Because I haven't included any secret management whatsoever. Okay, and I say yes. And we will get our plain text password. Okay, if you use competing tools, and I will not mention the name, that is what happens. The reason I know that is because I worked on those competing tools, and I know them very well, and I can see that's there. So as well as the arguments, Pulumi has what is called custom options, custom resource options. Custom resource options allow you to do a number of things. Import. If you have existing infrastructure that you want to import into Pulumi management, you would do it here. You would also do things like protect. Protect is an entire Pulumi level flag that means that your infrastructure will never be deleted by Pulumi. Okay? And if you set that when you're using things like S3 buckets or so on that are so crucial to your system, then at that point you can actually never delete them until you turn that off. Okay? But the most important thing is we have what's called additional secret outputs. Okay? Additional secret outputs means that I can take any of the outputs of the random password resource and encrypt them. Okay? Now, I'm going to remove it from this example, and I'll show you one side by side. Okay, so you can actually see. And I'm going to say constant encrypted password. I'm going to say encrypted password. And the additional secrets. And I know just because of this, it's actually called result because we're passing it out as result right here. So that's actually where the plain text would be stored. And I can say encrypted password. Now, can anybody tell me if it's going to be encrypted or not? Because they're exactly the same. They're exactly the same. I'm going to actually call it my encrypted password. So we think this one is still, of course, plain text. Yeah? What about this one? Can anybody tell me what they think? And why? More importantly, why? Okay, so I'll skip it. So the reason is that because we have said in the Pulumi state that we want to encrypt the output of result, when we go to retrieve the result, it will be in an encrypted format. Okay, so if I show you, Pulumi up, I'm going to say yes. We'll get, dash, yes, I apologize. So we'll get the top level one, which will still be the encrypted password, which will not change. And the second one will actually be secret. Okay. Not only is it secret in the output, Pulumi stack export, it is also encrypted with ciphertext in the state file. Okay, so secret management for us is extremely, extremely, extremely important. Really important. And it allows us to do different things. And we can even go further because by default, when we Pulumi config set, and we'll say my password, actually my DB password, and we're going to say my password 1234. And then if we go to our Pulumi application, we'll see a new file in here in a second. Maybe. Why are you not coming out? Oh. There we go. And we'll see in our system that we actually, by default, if you don't tell it that it's a secret, it doesn't know it's a secret. But if we encrypt exactly the same string with -secret, and we go back to our Pulumi configuration, it will use and store it as secure secret. Now I'm using the Pulumi backend here, so the SaaS. Okay, but if you want to do the same thing with another piece of information, you would say Pulumi config set --secret, secret provider, and you can say something like KMS and point to your KMS key. You can say Azure key value or key vault and point to Azure or so on and so forth. So we have support for external backends that you don't need to use the Pulumi SaaS. Okay, any questions? Okay, and then just to show you that the Docker example finished, we actually have 2 getting started endpoints. And we can go to our UI, and it'll take a second to start just because it's an application. So we should have 2. We should have one that says hello world, which will be from the Docker hub. In this case, there we go. And the other one will be like running my XP Days custom app in Azure, which when it starts, there we go, your custom XP Days Docker image runs in Azure. And if I really want to, I can go back to my code, and I can go back to my app, and I can remove it, and I can Pulumi up, and it will actually tell me that the only thing that needs to change will be the contents of the application, and it won't actually kill anything in the system. So you'll see again, it's doing the Docker check because that's actually, the Docker container has changed itself. And we can see that the UI comes out. We can have a look at the difference. And the difference will be is that it's a different version of the container. So the next level of the container. We'll say no here. 3 more slides, and I promise I've stopped boring you, and everybody can go and have lunch or whatever's next. So the SaaS gives us a little bit more, okay? This is like the 2 salesy slides, the 3 salesy slides. Firstly, we get full audit trail, okay, which is very important for a lot of organizations, especially when changes in production infrastructure need to happen. We have full dependency visualization, so you can see what happens when you change one resource, what are all the downstream potential effects of that resource. And we have CI/CD integration. So because of that, you can actually pull the information back into Slack or your CI tool using the integration and the GitHub and the webhooks. For us, we believe it's a much simpler way of managing the cloud. And we believe that we've been able to take advantage of using a lot more endpoints. So for those who are interested, there's some blog posts where we have taken a Helm chart in Kubernetes, which is this entire Helm chart right here. And we have redeployed exactly the same thing using 38 lines of Pulumi code. So using these higher level API abstractions means you don't have to worry about YAML anymore, which is always a good thing. So if you have any questions, please come and see me, just because I know I've run out of time. But I thank you for your time, and it's very nice to be back in Kiev again. I may have some time now for questions if anybody needs any.
Thanks. Can you tell more about state management, how you store it?
Okay, so the question is, can I tell more about the state management? Very good question. By default, the state management right now that I have is controlled by who I am logged in as. So if I say Pulumi, who am I? It'll say that the backend URL I am logged into is inside the Pulumi SaaS. Okay. Now I can Pulumi login, cloud URL, and I can actually say S3 and a location to a bucket, so that you're not even using the SaaS. We never even see any of your infrastructure or any of your code, and at that point you're actually storing it in S3 the same way as you would store your remote state from Terraform in S3. Okay? It's just by default ours is actually the SaaS, just because of the fact that we've gone a different way from Terraform here. By default in Terraform, it's local, right? It's local remote state. We don't believe that that's a good thing, because people get themselves into problems. I used to work on that team, the Terraform team, and I got myself into problems with remote state, because it's this JSON format looking file that's actually binary. And when you check that into GitHub or whatever source control, and other people try and check in the same file, the diffing around that is just a complete and utter pain. So we're able to store snapshots of the changes inside our engine based on what's happening. So the engine is clever enough to understand that when a change happens, in fact, I'll show you inside the app itself, and I'll go to our production environment so you can see it. And if I go and have a look at, I'll just show you our docs website. Look, getpulumi.com, and you can see that there are 2,426 resources under management here. And we go in and we have a look. Every time something changes, we actually are we store the diff. So in this case, look, nothing changed. In this case, just one thing changed and one was added. So we're actually able to understand these incremental diffs based on how the engine works. So the state management, it is not exactly, you can't say apples to Terraform. It is based in a different way. But by default, you can pass in any backend provider, like S3, Azure, GCP, Artifactory, Console, Vault, all these different things that's supported in Terraform as well. Does that answer your question? Any others? Now, if anybody wants to come up at the end and speak about it or like see any more examples, just come and find me. But again, as I say, thank you so much for having me.